Greetings, everyone. Welcome to the Emergency Management and Community Resilience Program and the Icdr Practicing Toward Resilient Futures speaker series. We're really happy for you to join us for part 7 of our series. I'm Jeremy Spoon, he, him, his, Director of the Emergency Management and Community Resilience Program. Before we begin, I would like to acknowledge that Portland State University is located in the traditional and ancestral homelands of the Multnomah, Cathlamet, Clackamas, Tumwater, Watlala bands of the Chinook, the Tualatin Kalapuya, and other indigenous peoples of the river known as Wemal, Nishiawana, and Columbia. We are grateful to be guests on these lands. Acknowledging territory shows recognition of and respect for indigenous peoples, both past and present. Recognition and respect are essential elements of establishing healthy, reciprocal relationships and developing a sense of place. This is a critical time to emphasize that humans and the environment are inextricably connected, especially during the global COVID-19 pandemic, and while wildfires, landslides, and floods threaten health and safety here in Portland and across the US West. Indigenous relationships with their ancestral lands can help folks recognize how human and the environments are one. Let us work together to honor their lives and ancestors, their descendants, and our own heritage. Thank you. So to begin today, I have the pleasure of introducing to all of you a little bit about the Emergency Management and Community Resilience Program at Portland State University. And I am so happy to share that our first cohort of students have come and joined us at Portland State. We have 18 students. Many of them are out there today watching the talk. And our goal with this program is to train the next generation of the workforce to engage these complicated problems that things like climate change, anthropogenic hazards, and just the general thrust of change and dynamicism that's going on in our world today. Portland State is positioning itself to be ready to engage these problems and to have our workforce have a very creative suite of knowledge to be able to do it. And our program at Portland State is doing that by combining emergency management and community resilience across all the different aspects of hazard and disaster risk management. And our idea is that our students can work under a theme instead of a general or traditional discipline. And those themes can engage different parts of how hazards and disasters occur, whether it is being part of the first response, the recovery, mitigating hazards to make sure they're not as bad the next time, or preparing for them so that all hazards do not turn into catastrophic disasters. Our program is for students that are looking for a meaningful purpose to apply the skills that they have to something in the real world that is increasing with intensity and severity. Our EMCR degree is fed by 6 different disciplines at Portland State: anthropology, communication, geography, geology, urban studies and planning, and public administration. And it's our goal that our students get a taste of all these different fields in order to weave together a patchwork quilt or put together a puzzle with different puzzle pieces in order to engage these complicated problems where we need really multifaceted solutions. Our students are also learning from faculty that do applied research all over the globe as well as locally, community-based research that engages hazards and disasters, especially related to climate change, is one of the strengths of Portland State University's research in general. And this graduate degree and graduate certificate are concentrating what we're good at and aligning us with partners in the community in order to provide our students with opportunities while they're in school to learn the skills that will get them the jobs in this emerging field. We offer a master's degree that's 53 credits, a graduate certificate that's 18 credits, and a non-degree professional certificate for the community that has 8 modules that are 4 hours each. If folks are interested in our program, we have an application that will be due in the spring. We do 1 application cycle per year, although students at Portland State that are already admitted and in graduate programs can add our certificate and come to us and talk to us about that if you're interested. We will also continue our speaker series just like this And it's actually going to evolve a little bit. And I'm going to tell you a little bit about that in a minute. But more than anything, I want to happily welcome our first cohort of EMCR students. And this is an opportunity for our EMCR students to interface with our community partners who are out there right now all over the world listening to this talk. And that's a spectacular thing that a lot of people have been working towards. And we're very, very happy to be able to say that our program is alive and in action. So if you want to take that step with us, check us out online. Check out our speaker series. Also, you'll see us in the community. Our program has a grounded capstone component that partners with different institutions at different scales in the communities, such as the Portland Bureau of Emergency Management and the County of Clackamas. And our students are getting hands-on skills and training as part of their degree work. So you'll hear about us, you'll hear, we want to serve as a resource and reinforce Portland State's mission to let knowledge serve through this very timely theme of emergency management and community resilience. So this is our last speaker series talk. They are all posted online. We will put the link for that in the chat. If you're interested, check out our faculty. We featured them throughout all of last year, and these are the wonderful resources that our students get to draw from in our core curriculum. Those are the folks doing these talks. And it's just so spectacular to think that the expertise that we have among these scholars are the core faculty that the students get in this professional training program. So sometimes you would be in a particular discipline and only have access to the professors in that discipline. So we're excited to be able to offer an amazing cadre of Portland State faculty to our emergency management students. So I hope you got a little taste of that in our speaker series. We had from 75 to 200 folks visit us from all over the globe in the first round. And we will be having a new speaker series starting in January. And we're shifting the theme a little bit to practicing resilient futures instead of toward resilient futures. And the focus of it is to provide our students as well as our community a little bit more of a sense of what it's like to work in this field and what are some of the cutting edge approaches and lessons learned that are going on that we can draw from for folks that are working in the field, want to enter into this field. And also there are so many different ways and entrees in which folks can operationalize their interests and work in this meaningful area. So we want to expose folks to that in our speaker series, both virtually at first and then in person. We hope that folks will get together and come to our events, mingle a little, talk about what it's like to work in the field, share your skills with the next generation of practitioners, which are our students. We're going to have both speakers and roundtables, and I think it's going to be a really provocative, creative space for folks to talk about what it's like to work, wanting to know some new ideas coming from the scholarly side, and also wanting to know what it's like to be in the trenches and really hear about the skills that are necessary to enter this field. So please join us starting in January. If you've ever signed up for any of our talks, you will get a list of all the talks in advance, just like this one, and we'll have the whole series planned just like we had the last one. So thanks for joining us on this last round, and we're really, really happy to have you here today. And also please join us for this new series, which is geared towards both community and our wonderful students. Okay, so here we are. So today I am so excited to share two speakers who both have talks that will have themes in common. Today we're going to hear first from Alida Cantor and then after from Heejun Chang. And the way the talks are going to work is that our speakers are going to talk, and then for about 10 minutes we're going to do a Q&A after that speaker's talk. And then we're going to introduce the next speaker, and then they will talk for about 20-30 minutes, and then we'll have another Q&A, and then both speakers will be available at the end for the Q&A. And please put your wonderful comments to the speakers in the chat, but put your questions in the Q&A, and that's where we'll draw from when we facilitate the Q&A. So thank you for that. All right, it's my pleasure to introduce our first speaker, Alida Cantor. Her talk, Resilient Water Governance. Alida is an assistant professor in Portland State's Geography Department. She's broadly interested in human-environment interactions and political ecology with a focus on water governance in the Western United States. Her research examines the legal processes shaping how water resources are managed, the intersections between energy, food, and water, and social and environmental justice. She teaches and advises students in the areas of resource management, water, food systems, and environmental policy. So join me today in welcoming Dr. Alida Cantor. Thank you.
All right, thank you so much, Jeremy, for the kind introduction. Let's see, I'm gonna share my screen here. All right, I hope you all can see that. Yeah, so I'm going to be talking today about resilient water governance, and in particular focusing on drought. So we'll have drought first, and then Heejun will follow up with talking about floods. So Jeremy already introduced some of my interests in my research. I teach in the EMCR program a couple of the electives, including water resource management, geography of food, and some special topics in resource management. I'm really excited to be a part of this program and to connect more with the students going forward. So today I wanted to talk about, instead of a standard research talk, I wanted to stitch together some of my interests and some of the things that I've been thinking about for some time, and sort of connect those to the theme of emergency management, and so just try to connect some dots here. So to start out, I just wanted to pose this question of what are these connections between emergency management and water? And it may seem, if you're interested in emergency management, maybe it seems obvious or maybe not. But in fact, there's just so many ways that emergency management really is water management. So whether it's between areas of the water cycle that cause disasters, we're talking, blizzards, ice storms, mudslides, droughts, or things like failure of critical infrastructure, like dam failure, water infrastructure failure, contamination of drinking water, storms. These are all related to the water cycle. And in particular, I think that it's important to think about climate change as water cycle change. And so many, if not most, perhaps, of the ways that climate change actually impacts us in terms of disasters is through changes in the water cycle. So we have changes in precipitation, timing and amount of snow and rain can lead to floods, droughts, sea level rise, hurricanes, storms. So all of these are climate change related disasters, but they're also water cycle disasters. So in my classes around water, I often start by just thinking about what are the issues when we think about water resource governance. So we've talked about what disasters are related to water, but how do we govern water, and what are sort of the problems with water resource governance? So there's, obviously too much water can be a problem, right? That's where we're talking about floods. Too little water can be equally as much of a problem. We also get into equity issues. Water can be too expensive to the point where it's not accessible, right? If water costs too much, then it can be inaccessible. Water can be too contaminated, and those can be related, right? Where clean water can be too expensive. Predictability is a big one. We need water to be predictable enough that we're getting what we expect, so to speak. So when we get far more than we expect or far less than we expect, that can be a problem. And then as a geographer, I think a lot about questions of distribution, and water can be unevenly distributed. So maybe there's the same amount, but it's coming in different places than we expect, or it's both geographically unevenly distributed and also socially unevenly distributed, right? So we can talk about who gets access to what water. So all of these are questions about, too much or too little or too expensive for whom and under what circumstances. And then when do these issues become an emergency rather than just a phenomenon? So that's sort of an overview of how resource governance connects to emergency management. So one of the things that I like to talk about with my classes on water is this question of what makes water special. So, we can talk about any resource, but water is I think, a particularly interesting one, and a particularly special one for a number of reasons. So some of the things that make water special, water has specific material properties and also social properties that make it, that impact governance. So first of all, water is non-substitutable, right? Every living thing needs water. And so we can't live for very long at all without it. And that includes humans and non-humans. So that makes water particularly special when we talk about governance. It's unevenly distributed, and the way it's distributed doesn't always equal how demand is distributed. Water is a solvent, so it dissolves and it transports pollutants. It can shape geology over time. Water's heavy, so it's hard to move it from one place to another, which makes some solutions just unfeasible. I think every time there's a drought, some solution comes up around, like, let's just like truck water around or use pipelines, and like the heaviness of water makes all of these basically unfeasible. Water flows, it seeps. The way water moves matters. So it connects people in places. It also transports things that we don't like disease and pollution. Water doesn't respect political boundaries. It can be, we have transboundary aquifers and rivers that go across boundaries, and those political and water boundaries do not always match up. Water's not always visible. So especially when it's underground, this makes management hard. Groundwater management has been historically really challenging, and part of that is just that we can't see it, so it makes it harder to manage. And then finally, waters have meaning. So there's specific cultural and spiritual value attached to specific waters in specific places. So it's not always interchangeable. We can't just switch one water for another and have that be the same. So that's a little bit of an overview of how I like to think about water in terms of emergencies and also governance more broadly. So I want to switch gears now here and talk about drought. So you may have been following, I think over the last 10 years or so, we've seen a number of long, large droughts in the Western United States. This past summer, there was a lot of drought happening in Oregon and the Western US more broadly. This particular map is from September 2021, so not too long ago, and you can see big swaths of the Western United States under drought conditions. So when we talk about drought, what are we talking about? There's a couple of different ways of defining it. There's a meteorological drought, so that's just about how dry, the amount of rainfall deficit and the length of the dry period. So how much would you normally expect, and then how much are we getting? Hydrological drought is talking about the impact of those rainfall deficits on the water supply, how those impact reservoirs, lake levels, groundwater table levels. So you see like sort of building like from precipitation to what that means in terms of storage. And then to take that one more step, we can think about agricultural drought as how agriculture is impacted, how soil water is impacted. And then like sort of a level up from that is socioeconomic drought. So thinking about the impacts of drought conditions on supply and demand of products. So these are the sort of traditional drought definitions. To me, these don't fully capture the whole picture with drought. I think that there's also equity dimensions. So how do drought conditions impact people's lives and people's livelihoods, which I don't think are adequately captured in any of these other drought, like standard drought definitions. There's also sort of socio-ecological drought. So how does a drought impact, given maybe impacts of human overuse or historic overuse, things like groundwater overdraw, then you add a drought on top of that, and how does it impact other species, non-human animals and plants who need water as well. So we can think about drought as a relationship between supply and demand. So one thing I like about this map is it's not just about the amount of precipitation, but it's about what we expect to be able to do with that precipitation. And so this is looking at how much of the year area is under scarcity. So thinking about that the demand is more than the supply that's available. But this doesn't fully capture what drought means for everybody. Drought is also about power and inequity. So this is a case study that I use in my water management class to talk about drought. This is looking at 2014 to 2015 were some of the most serious drought on record in California, or in recent record at least. These pictures were taken close to one another geographically. This is both in California, but these water users are both experiencing a very different experience of the drought. So on the one hand, we have Oprah's estate. And so Oprah was able to bring in truckloads of water during the drought to keep her giant lawn green. On the other hand, we have a woman named Juana Garcia who lives in East Porterville, California. And in this area, the groundwater tables dropped low enough related to industrial agricultural overuse of groundwater that the domestic wells in the area actually ran dry. So residents were washing their dishes and their children with bottled water and didn't have enough water to just have water coming out of the tap when they turned it on. So we can just see that drought can have really different impacts depending on resource access. Which brings us to sort of a more academic method of thinking about it. This might be familiar to many of you who have been thinking about disasters and vulnerability. So this is the vulnerability assessment model that combines not just exposure. So, when you have a drought, you might have reduced precipitation, but also sensitivity. So how systems might be impacted by the drought. So for example, in that case, how deep are the wells? How deep are trees' root systems? And then also adaptive capacity. So the ability to get water from other sources. If you had a lot of wealth during the drought, you could just bring in tanker trucks. So the ability to adapt and continue to function. And so these three together can be a basis for thinking about vulnerability to drought and which people and communities are most vulnerable, and also what ecosystems and non-humans are vulnerable. So there's all kinds of impacts of drought that we can think about, right? So we talked a little bit about threats to domestic water supplies, especially small systems and groundwater dependent systems, threats to crop, livestock, agricultural production, recreation. You can think about energy system impacts, so like decreased hydropower production, water quality issues like increased risks for harmful algal blooms, wildfire risks, ecological impacts, including for endangered species, and then sort of how adaptation and coping strategies might cause other problems like overdrawing groundwater to make up for lack of surface water. So drought isn't just one thing, isn't just one impact, it can impact all these different sectors in different ways. All right, so now I want to turn to talking about management of droughts. So this is likely a very familiar diagram to many of you. This is how we're supposed to manage emergencies, right? Mitigate, prepare, respond, recover. Drought in practice often looks a little different. This is a diagram that I've seen, I think it was made in like the 70s or something, when there was also a drought. And I really like the hydrological cycle here. So we go from drought can raise awareness and concern. So people might change their practices at that point of concern and maybe even panic. And then there's rain, and rain leads to apathy. And apathy then gets us to the next drought. And one of the reasons I think that this happens, that this cycle of rain, apathy, drought, is that drought can be thought of as a sort of a creeping disaster. So you might have seen like similar cartoons talking about climate change, right? With the metaphor of the boiling frog, that it happens so slowly that we don't realize it until we're really bad, like things are really bad. And drought, I think, can be the same way in that it sneaks up slowly and you don't always realize how bad it is until it's like too late to do much about it in a meaningful way. So we saw a bit of a case study of this in Oregon this past summer. So this is a drought map from July, and in July, Governor Brown directed state agencies to act because of drought conditions. And I want to take a look at the executive order that was issued and sort of take a critical look at it and break it down. So Governor Brown in July 7th, 2021, so just a few months ago, really, issued an executive order to deal with the drought in Oregon. And so some of the key provisions were to end non-essential use of water at state buildings, including lawn watering and window washing. Okay. A moratorium on installing new non-essential landscaping that required irrigation at state-owned buildings. So that's important, right? Because it gets us to some of the more structural water uses. Like if you install a landscape, then you're stuck with it for a really long time. So that's important. And then placing signs in state buildings to encourage state employees to reduce non-essential use of water in state buildings. So just raising awareness. So, these are all something, and something's better than nothing. But to me, there's a lot missing from this. And part of it, I think, is just a proactive policy. Like these are reacting to a current situation with a pretty limited toolkit. And it's saying like, okay, here we are right now, let's do something. So that's maybe in that, action panic sector of the hydrological cycle. But it's really about reacting to the moment rather than planning ahead. It also misses a more comprehensive approach. And so, but by limiting it to state-owned buildings, it's a quite small sector of how the state of Oregon uses water. And that's particularly, we use the Western US in general. A lot of our water goes to agriculture, broader industry and municipal water use as well. So, I understand like Governor Brown's authority is maybe limited, but, it's really getting at a very small slice of water users. There's also the question of data, like do these measures even work? How do they compare to other possible measures? Is this data-driven policy or is it just like doing something in the moment? And then finally, questions of evaluation. So do we know if these measures are working? Are they going to be adjusted if they don't work? Or are they just being done to make people feel like something's being done at the moment? So some colleagues of mine in California have done some analysis of past droughts in order to inform how we look at future droughts. And so they're trying to break out of that hydrological cycle where rain leads to apathy until the next drought. So it's saying instead of apathy, that's the point where we really should be planning. So some of the key lessons that this team came up with were to make policy decisions in advance of droughts rather than waiting till July where a drought is happening. Improving data and information availability between and ahead of droughts is really important. Learning from previous and current droughts, so studying what's happened before, what worked and didn't work. And then finally, just enforcing what we already have. So enforcing laws and water rights systems that are already in place I really like this quote that I heard the other day, that regulation without enforcement is just a suggestion. So to sort of bring it all together, I wanted to also add a few broader context elements to drought management or to thinking about drought management. So these are a bunch of the things I study in my research that sort of provide some broader framing for thinking about droughts. So one important thing to remember is that agriculture uses 70 to 80% of water in the US West. So if we're looking at municipal lawns or state government lawns, we're missing the big picture, right? We're missing like where the water is actually going. We also have a legal system in the Western US that does not incentivize conservation. And so we have a water rights system that grants water first in time, first in right. It's called the prior appropriation system. So senior water rights holders basically will always get their water, even in a very severe drought, and have no incentive to change any of their practices. And our water rights system is very static, not dynamic. It's really not very adaptive to the new normal of climate change and varying precipitation regimes. So that's a big issue. We often see groundwater being overtapped to make up for surface water deficits. So groundwater and surface water are measured and regulated differently, and that's a big problem. Water quantity and water quality are also regulated differently. And so often, thinking about water supply is disconnected to thinking about water quality. And finally, more broadly, our whole water allocation system in the Western United States is rooted in settler colonialism, has huge inequities attached to it. And so, these broader questions of who's systematically excluded, undervalued, or overlooked in water governance more broadly, and then how that gets heightened in times of drought. So to wrap it up, these are some key takeaways that I hope you'll remember from this talk and thinking about resilient water governance and about drought in particular. So the first is just that systems are interconnected. So lots of emergencies are water related, they're water emergencies. Climate change is water cycle change. Another key point is that we have to plan ahead. So especially for these slow creeping disasters, it's really important to not wait until it happens to think about it. So to get out of that apathy part of the hydrological cycle. Another key point is to think big. So often during times of drought, there's recommendations like, policies will come out like restaurants shouldn't serve glasses of water until somebody asks. Like that was an actual policy during the California drought. And that's like totally missing the point of it's like tinkering around the edges rather than getting at the actual problem. So if people are talking about glasses of water or gallons of water, they're usually missing the big picture of acre feet of water, which is the amount of water to flood a football field 1 foot deep, and is the measurement used in water resource management. So it's important to think about where the water actually goes, which is likely, not the tap of your house to fill up a glass of water. It's agriculture. In terms of residential areas, it's leaks and lawns. So focusing on the big picture of where the water's going. And then finally, equity matters. So drought clearly does not affect everyone equally. And then just back to that point that water is non-substitutable. Everybody needs it. We all need clean, safe, sufficient, affordable water, whether we're human or non-human. So I will end there and invite anyone who's a PSU student to join me for my water resource management class in the winter if you want to think more about these issues.
Thanks so much, Alida. Josh, why don't you give us a little bit of background on Icdr next?
Sure, happy to. And thank you, Dr. Cantor, for your wonderful presentation. And thanks everyone for joining today. We have a great turnout, and it's always great to see community members, folks work in the field to join for this ongoing speaker series, which is very important that we continue this discussion. My name is Josh Metzler, Programs Coordinator at the PSU Center for Public Service in the Hatfield School of Government at PSU. I'm also the coordinator for the Initiative for Community Disaster Resilience, or Icdr, which is the co-host unit of the speaker series. So a little bit about Icdr. We were founded in 2017 with a mission to provide a platform where experts from the academia, government sector, for-profit and nonprofit organizations can exchange information and discuss emergency management, disaster preparedness, and other resilience-related topics with community members in our region. Since its creation, Icdr focused on 2 activities. First is this lecture series where we're co-hosting with the EMCR program, as well as our own speaker series we've done since 2017. The other one is to organize an international field trip to Japan. Of course, this was pre-COVID when we were able to travel. So since 2017, we've conducted 3 of these international field experiences to Japan, took students, professionals in the field, to Japan, to the disaster-affected areas in the Tohoku region. So that's a little bit about Icdr. We're glad to be part of this effort of the speaker series. Back to you, Jeremy.
Thanks, Josh. Now we're just, folks have questions for Alida. We're here to facilitate them. So send them in the Q&A. Alida, why don't you come back on for a few minutes here? All right. So this is a question from an EMCR student, Alida. Do you think using water pricing is an effective way to build resilience or to induce innovation or conservation? How would that look?
Yeah, thank you for that. That's a great question. Thank you for that. I guess the short answer is yes and no. And the little bit longer answer, I think on the one hand, water pricing can help to shift away from sort of low value water uses. So in the Western United States, thinking about California in particular, this is something I'm writing about right now, actually, is about one of the biggest water users is alfalfa. And I can rant for a really long time about alfalfa. It's one of my favorite topics, but basically it's a huge water user, and it's very, very low value, and it doesn't make very many jobs, and it sort of indirectly contributes to climate change by keeping beef and dairy cheap. So there's all kinds of problems. And so one of the things they've been able to do is use water markets to where cities can pay farmers to keep their fields fallow and to be growing less alfalfa because it's cheap. And it's like not a very efficient use of water anyways. And so you can actually shift water away from alfalfa to sort of higher value uses. So that's an important thing to be able to do. One of the things I think, though, where water markets fail, or one of the problems I have with them, is thinking about just who is able to participate depends on who can pay, right? And so back to that, like, water is non-substitutable. Every living thing needs it, but not every living thing can afford to pay for it. And so the more that we put water on markets and treat it as like a market commodity, the more risk I think we run of people without much money, or other animals and other species who don't have money, then lose the ability to participate and to ensure that they get water. But yeah, that's a great question.
Thank you. Okay, here's a follow-up. Alida, are there any best practices or even breakthrough results that other countries with severe water challenges have reported? How do some of those practices lead the way toward your own research and findings? Hi, Don, friend of the program. Go ahead, Alida.
Yeah, thank you for that question. I think one of the countries, looking internationally, Australia often is used as a model for the Western US, or there's sort of a lot of information exchange between Australia and the Western US. So, some of the things that they've been able to do are really applicable to what we can do here. And I think that, again, some of the challenges, so there's a lot of like research on, say, like something like water markets, how that works in both the Western US and Australia, and they can sort of share information back and forth and see how it's working in one place and what lessons might be learned for other places. I'll add to that, I think, in terms of best practices, we do have a lot, like just in terms of technologies, we've seen urban growth without water use growth over the last several decades in most US cities, which is great. So looking at, like populations in cities can grow like this, and water use actually stays flat because we're implementing more things like low flow toilets and getting rid of lawns and like doing all those water conservation practices. So there is a lot of great tech out there that does help us save water, and just like putting it into practice works.
All right, and next question. Oregon is only now just quantifying water rights. What is being done to address these issues at this relatively early stage?
That's a great question. I don't know a huge amount about the ongoing process right now in Oregon. I do know that like quantification of water rights can be a really long process. I think in other places, I'm thinking of a geographer who did a study on adjudication and quantification of water rights in New Mexico, and the amount that they paid out lawyers over decades was actually more than the water itself was worth over, like, that amount of time. It was like literally, it was like people's children were taking on the struggles that their parents had started with quantification of water rights. So I would just say that I'm not sure I expect it to solve the problems in a timely fashion, and quantification shouldn't be the only strategy on the books.
All right, last question. We currently have a generally selfish political climate, which makes living up to Wendell Berry's watershed golden rule, do unto those downstream as you would like to have upstream unto you. How do we think big and do big when we're not willing to be generous across so many issues?
That's an interesting question. I guess I would put in a plug for policy. Like if you can't just sort of magically expect people to be nice, you can regulate them. And that's true with, whether it's water quality, water quantity, just, making rules and enforcing them, I think is really important to protection of people and non-human species.
Thank you, Alida. Oh, sorry about that.
Yeah,
go ahead.
Thank you so much. No, I'll just end there and just thank you so much for the really interesting questions. I appreciate it.
Thanks, Alida. And Alida will be around at the end of the talk as well if you'd like to ask a follow-up. It's now my pleasure to introduce Heejun Chang. The title of his talk is Flood Resilience in the Anthropocene. Dr. Chang is a professor of geography at PSU. He holds a BA and an MA from the Seoul National University and obtained a PhD from the Pennsylvania State University. Dr. Chang has led transdisciplinary water research from a coupled natural and human systems lens across the Pacific in studying future climate change impacts on water quantity and quality and flood hazards using spatial statistics, social surveys, and process-based modeling. Dr. Chang is the editor of the Professional Geographer, published by the American Association of Geographers. He's published over 150 peer-reviewed manuscripts and has 7,000 citations on Google Scholar. It's an absolute pleasure today to welcome Dr. Heejun Chang.
Thank you, Jeremy, for a very nice introduction. It's my great pleasure to talk to you about flood resilience. Now we are turning into the wet season. You may see more nuisance flooding. This research is probably more than like 2 years of my research in collaboration with others. I'm going to share some gist of some findings to share with you. And okay. I'm moving. Okay, so we live in the Anthropocene. So the Anthropocene is the age of humans. So as you see in the right-hand side, the world population grew substantially. So when I was born in late 1960s, the world population 3.6 billion, but now it's close to like 8 billion. And the world population is projected to increase continuously until about 2050s. And depending on the projections, we see further growth or some slowdown. So what this means is that we created a lot of problems and issues, and the piecemeal approach is not going to work. But we also have the opportunity to solve these problems. So you know that the climate change is a big one, and this map illustrates which part on Earth has a temperature increase over the past century or so. The red illustrates the high increase in air temperature. The blue shows the decrease in air temperature between 1901 and 2012. And you can see the majority of the areas on the globe, the temperature increased substantially. And also we can overlay this the city growth. So you see a lot of urban areas grew between like 1% and 5% in some parts of the world. And you can see much higher growth, in particular in East Asia, for example, here, and South Korea and Japan and China, most of the coastal cities, and the city become much larger and bigger. So you can see the double challenges of urbanization and climate change and how the cities can prepare for those change as relate to floods and drought. And this map shows the potential changes in future return period in terms of a 20-year annual maximum 24-hour precipitation. So you can see those box whisker plots shows the range of changes in the future compared to the historical period. The historical period used here is between 1981 and 2000. So we look at the distant future, near future, and the distant future. So near future is the mid-21st century, and the distant future is the late 21st century. So this is based on many different climate change simulations, and we look at the change compared to the historical period. As you see, in the near future, the return period changed from 20 to 10 to 15 years. But in the distant future, the return period interval becomes much shorter. What that means is you get more extreme precipitation events. And those three bars illustrate different emission scenarios. The red illustrates the highest greenhouse gas emission scenarios. Under that scenario, you see much higher chance of extreme precipitation events, which can translate into flood events. And you can see the Pacific Northwest, the 20-year event may become like a fewer than 10-year event by the end of 21st century. Similar patterns are found in East Asia. So those are the two areas that I'm going to focus on for my talk. So the climate change is not the only thing. You can see in the local area, I compared whether the urbanization is affecting the peak flow event in the Portland metro region. So one in Johnson Creek, as you know, it's much urbanized and urbanizing regions. The annual peak flow has substantial increase in the past 20 years. Versus in the Sandy River, the rural areas, the peak flow didn't actually increase. So this illustrates the urbanization can be a significant role in terms of increasing of flood risk. So when you talk about floods, there are three different types of floods. One is fluvial floods. It's also called riverine flooding. So it's an overflow of water due to excessive rain or like a snow melt. And the second type of flooding is pluvial flooding, which is also called flash flooding or surface flooding or nuisance flooding, street flooding. So you may see like a street flooding these days because all the leaves are falling on the ground and they may clog a storm drain. So the storm capacity exceeds, the precipitation exceeds the capacity of the storm flow, and then you can see the overflow of water and street flooding. Or the other case is that some distant areas, the water gets saturated and the debris flow. So this may happen in flash flow in arid desert when there is a heavy storm and there is a big flash flood. The third type of flood is coastal flood. This is due to like a storm surge combination with a high wind, so inundating the nearshore areas. So the reason why we need to distinguish those three different types, the causes of floods and the impacts are different. So we need to come up with different strategies to cope with those different types of floods. So when we look at floods, there is a framework called Socio-Ecological-Technological Framework. And I'm going to briefly illustrate what this is and how it's useful for understanding flood risk management. So the cities have both a people and the nature and infrastructure. We have to understand the interaction of all those three components together. I'm really glad Alida set a really nice setting for my talk. So the water is a really complex issue, but it's encompassing all different parts. So many of those elements, when you create those like infrastructure, those are the public goods. And those infrastructure has long lifespan. What that means is if those infrastructure ill-designed, it's going to have huge consequences down the road. So we have to ensure to have the right design for land and infrastructure and other public goods. So the urban flood risk management rely on those interaction and feedback. That's why using those socio-ecological framework may be useful. In addition to that, when we look at floods, we have to understand the learning loop. So when there was a flood, how long people's memory may persist and what kind of actions are taken after that. So there are three different types of learning loop. One is single loop. This is more like a reactive approach. You increase the height of dikes or levees after floods. So it's more like a post-flood mitigation effect. And the double loop is moving a little bit forward. You want to change the framing. Let's say the climate is changing. How do you ensure that we're going to look at both surface water and groundwater together? Or maybe we need to look at flood, the water quantity and water quality when there was a flood and how the different sectors can work together. That is more like a double loop learning, a reframing, but it's not fundamentally shifting or transforming. So the triple loop learning is the most transformative. You change the entire context of your problem. For example, whether you want to actually move people out from flood-prone area rather than creating dams or rather than creating parks to capture water. But it does require a fundamental shift in thinking and philosophy. So I combined those social learning and socio-ecological framework, which is called the SET learning framework. So to understand how cities have been dealing with floods in 3 cities. So this is, again, you can see in the triangle, the SET, S stands for social, E stands for ecological, T stands for technological. So in the past, we only consider the past flood events, and we do not consider climate change, but you have more technological components dominant in the system, just using levees or other infrastructure to cope with flood. So this is more like a single loop, and the double loop learning is moving a little bit forward, and now you consider future flood risk, and there are some interaction among those different components within the SET system, but still the technological dimension dominates, the ecological dimension is not pronounced, versus more like a triple learning loop. Now you see the entire component of the system is interacting much more, and you have a more tightly coupled system, but you also change the entire context. So what do we understand this? So we look at some governance document to understand what documents represent social element and technological and ecological, and we categorize those. So the 3 case studies I'm looking at is 3 cities, 2 in East Asia, 1 in Portland. The reason I chose those 2, so I'm originally from South Korea, so I'm very familiar with the city and how the city has been dealing with floods. And also I had I'm fortunate to have a chance to go to Tokyo as part of my sabbatical, and I studied flood resilience as part of my sabbatical research. So I was comparing those 3 case studies. You can see all those 3 cities have substantial population growth since after World War II. In particular, in Tokyo, so between 1950s and 70s, but the Tokyo's population has slightly declined after like the 1970s, although it went up since 2000. In Seoul, the population grew exponentially until about 1990, and then slightly moved down and stabilized. In Portland, you can see the most growth happened since 1980s. So the population growth has huge consequence on land footprint. You can see in these 3 maps illustrating land cover change between 1910 and 2010. And red illustrate the urbanized area versus green areas, forest and rice paddies all disappeared as a result of land intensification. And not surprisingly, those lands typically land conversion happening along the transportation corridors. So the research question that I'm addressing. So first, I'm also looking at what explains the spatial patterns of flood damage, what climatic, what landscape factors explain that. And second, how flood risk management policies changed over time in response to any major flood events. And finally, what kind of strategies have been implemented to reduce flood risk in those cities? Are there some commonalities? Are there substantial differences? So the research framework, this is more like a mixed approach. And the first part is doing policy document review, and we identify some set of indicators. And we also conducted expert interviews. And the second part is doing more GIS spatial analysis using both climate and land curve analysis and how those relate to flood damage. And finally, I'm interested in looking at the integrated flood risk, combining both quantitative and qualitative results. So just to give an idea about how the land cover change analysis is done. So this is part of Seoul in 1910. So when Korea was the colony of Japan, the Japanese government created a very detailed map, which provide opportunity to reconstruct the past land cover conditions. So my colleague and I reconstructed the land cover in 1910 based on these old historical topographic maps. And we are conducting also similar parallel studies in Portland in collaboration with my graduate student and David Bennis and the Department of Geography. And we mapped all the disappeared streams in Portland. So we are also interested in relating that to flood risk. And then how do you reconstruct the past land use then? So let's say this is the land cover in 2010, and a part of that area is urban. So we look at the urban area in 2010, but maybe back in 1910, the area was forest, but the forest was converted into agriculture in 1990, and then maybe converted into urban area in 2000. So basically identify the proportion of the area in each of those districts and what the land cover condition was in previous years. So the more forest or agriculture or urban area within the current existing urban area that illustrate you have higher potential flood damage because you get more impervious surface areas. So we did look at digitizing all those old channels and compare how a channel has been strengthened as a result of urbanization. This illustrates one district, it's actually Gangnam district, if you recall it, a single size Gangnam district. This is the area, the south of the Han River, which has upscale neighborhoods. And this picture was taken in late 1970s when the apartment was building, and in front of that you still have old houses. And you can see all those meandering channels completely disappeared. And this area is much prone to floods. And so they create levees to protect flooding in this area. So we use those data to compare what may explain the flood damage. And this map illustrates the district level flood damage. Not surprisingly, the most urbanized area in Seoul here in the upper left corner, and the second largest city in Busan. So they have the highest flood damage per area. And these two areas in northeastern corner of the country, this area got hit hard back in early 2000 by typhoon. And also in coastal areas also more prone to flooding. And we look at both the flood damage in the previous decade, as well as precipitation and housing density and park space, and percent natural areas in the historical period. So, and then this is the results of our spatial analysis. We use both ordinary least regression as well as hierarchical linear model to understand the effects of those explanatory variables. So the first set of variables are the regional memory effect we name, and the flood damage in the 1990s and 2000. So you can see the flood damage in the 2010 is highly associated with the previous decade's damage, which is not too surprising. In other words, those are hotspots, they're always problematic. The things haven't actually changed much. And as you recall, Alida talked about those vulnerability dimensions, the adaptive capacity, sensitivity, and exposure variables. So these are the sensitivity. The higher the housing density, the higher the flood damage, which is positively associated. But if you have more park within the district, those parks can actually absorb the rainwater. So you have this is adaptive capacity, which is negatively associated with the flood damage. But all the exposure variable, this is showing the land cover in old years. The more water or wetland or forest area in the previous decades, those are highly associated with the flood damage. So it confirms our hypothesized relationship. So the precipitation is also significant at a larger regional level. And the second part is doing some document analysis and flood interviews. So we recruited experts by snowball sampling, approximately 10 to 20 people who are interviewed in each city. And we also look at two different types of documents. One is city comprehensive plan, and the second, the hazard mitigation plan in 2 different years. So we try to understand the change over time, how the set's dimensions may have shifted over the years. So just a gist of some interesting findings about flood expert interviews. So this is the perception of flood by different type. Remember that I talked about 3 different types of flooding. In Portland, all those cities, they say that fluvial flooding is the most significant concern in both Portland and Seoul. But in Tokyo, the fluvial, the riverine flooding is the most significant. The higher the number, that means higher the risk perception. So not surprisingly, the coastal flooding is much lower in both Portland and Seoul. But in Tokyo, all those 3 different types are almost about the same. We also asked practitioners what kind of strategy they prefer to use. So this is, again, we give about 25 different strategies, and we map those out. The 6 strategies represent social, and 6 represent ecological, and 6 represent technological. And ST, this is a combination of social technological and eco-technological. So eco-technological is such as like a green infrastructure, and social technological is the science and development or early warning using some technology or app applications. So some cases, those strategies overlapping more than 1 dimension. So you can see each city practitioner responds slightly differently. In Tokyo, and social strategy probably the most important. In contrast, in Seoul, the technological strategies become the most important. In Portland, I think social, ecological, and technological somewhat. Social strategies are most important, but technological and ecological strategies are equally important. SET, that set strategies are used, such as like managed retreat and willing settlers program. So we move people out, and then we convert that into a green space, this kind of sets dimensions. So you can see that people have different strategies, nature-based solutions to completely raise the height of the levees. And also we did a document, a content analysis. So this is based on, we identify the relevant code, and then we code those areas and try to link those relationships and identify some major themes. So for example, this is the original code in one of the documents. So we should say maximize life safety or preventing life-threatening situation. That belongs to the emergency response. This is part of social dimension. And when you look at like a natural flow or green space or wetland, that is nature-based solutions. This is called ecological dimension. When you talk about any seawall or flood wall, that's infrastructure construction, that belongs to technological dimension. So we map all those out, and here is the results of the analysis. So in Portland, so we have, I mentioned that there are 2 different types of documents. One is city comprehensive plan, and the other is hazard mitigation plan. So you can see shape of the polygon in the spiral diagram, and the size of the polygon tells some interesting things. The shape illustrates so which strategies are preferred, either technology or social and dimension. If the axis is moving, and that illustrates this particular component becomes more important than the others. And if the size becomes bigger, that means you see more frequent calls related to those dimensions. So in Portland, you can see back in previous, like early 2011, the social and ecological and technological strategies are more mentioned, but in 2018, so more ecological, like a conservation, restoration, you can see higher code on ecological related strategies. In hazard mitigation plan, we did not see any mention in ecological strategies. But in Seoul, it gets really interesting. You can see the polygon size become much larger, but also the direction of the polygon is shifted from technology to social. So in the previous era, the technological strategy predominate, but it becomes the social or ecological dimension become more important in the later years. In Tokyo, the technological strategies still dominate, and the shape didn't actually change much, but the size of the polygon becomes larger. In all three cases, in hazard mitigation plan, we did not see any emphasis on ecological strategies. So so looking at this more at the historical perspective, so we had some major flood events. I was curious of what may explain those. Are they related to any change in precipitation or flood events, as well as any policy in response to those? So there was a big flood in mid-1984. I do remember I was a freshman in high school. The Han River got inundated, and that was the year actually North Korea sent rice to South Korea. And this is associated with continuous rainfall for a prolonged period. This is more fluvial riverine flooding. And the country has done some work in terms of revising the river restoration. But in 2000, the nature of precipitation shifted. They get more torrential, heavy rainfall, which is potentially related to sign of climate change. So which inundate the city hall, you can see in the picture down here. And the city spent a lot of resources starting in 2010. And they increased the design standard, and they constructed some underground tunnel to capture rainwater. So in Tokyo, so Tokyo's case was also interesting. In general, the flood damage somewhat declined, but still there's a lingering precipitation. And they constructed a super levees, which I will explain in a minute. So in both Seoul and Tokyo, they are heavily populated cities. So in other words, there's not much room for them to create any new green space. So the only way they can capture rainwater is to construct really big underground discharge channel, which is shown here. It's about 60 feet high. So during a high flow season, this is completely filled with water. So all the water from the city street go into this area. So this is one way how the technological fix becomes important in managing floods in Tokyo. But again, they're also concerned about the climate change, and they get more localized. Particularly in 2019, when I was there, I felt the power of typhoon the first time in my life. So there was a Category 5 typhoon that hit Tokyo metropolitan area. So what they did is they tried to integrate those different laws all together. So in the past, they have 4 different laws. One is specifically focusing on urban and fluvial flooding. So the other one is focusing on fluvial riverine flooding. So those were completely separate. But as a result of the big floods, now they create a new organization that can oversee all those different laws, and then they can coordinate things better. In Portland, so this is, we didn't have much flood compared to those 2 cities, but we did have like a 1996 in 2015. So but Portland is among more proactive, and then the flood protection was listed as one of the reasons for policy in mid-1980s. And then Johnson Creek Basin was also recognized as spatial area because it has a long history of chronic flooding. And also the city of Portland is the first city that initiated the Climate Action Plan in 1993. And the city also initiated the Willing Sellers Program. This is asking the homeowners to sell their house voluntarily, and the city purchased it, and they converted it into the natural areas, which lasted about 15 years. But also, we may see the increasing frequency of atmospheric river, which is, shows a narrow band, water band that dumps a lot of rainwater into the Pacific Northwest. So as the ocean temperatures get warmer, we may see more frequent atmospheric rivers. So to summarize, there are a couple of case studies I'm going to illustrate how we can map this in set dimensions. So in Seoul's case, there is a major Seoul and the restoration project, so which goes through downtown Seoul. And it was a symbol of modernization in late 60s and 70s. But there was a lot of problems of old aging infrastructure. So the mayor of the city back then decided to remove and uncover the stream. This illustrated during the construction and what it looks like now. But at the same time, you need to prevent flooding. The only way you can do it, you can deepen the channel because the surrounding areas already got developed. So unlike the early 20th century, the river was much wider and shallow, but it's much deeper now. In Tokyo, as I said, they constructed super levees, which is much wide levees compared to conventional levees. It's about 200 to 300 meters wide. And then you can construct like apartment building. You can actually have a view, unlike a conventional levee, all the views are blocked by the levee. But also you embank soil in the super levees, and then this is more resistant both flooding as well as earthquake. You can actually prevent both type of hazards by creating this super levee. The downside is it's going to cost a lot of money and also the community buy-in because they have to remove at some point and then come back later. In Portland, as I said, the Willing Sellers program completely removed like 60-something houses in Johnson Creek. You can see the Google image illustrating before restoration and after restoration, and all those streets that connect to the Southeast Foster Road, they got removed, and these areas are now converted to natural areas. So how we map those three cases together here. So if you look at the set dimensions, so I consider the Willing Sellers program is more socio-ecological strategy. So you have a permanent displacement of residents. So people won't come back, but it's pretty much going back to the nature. In Seoul, you mimic the nature, but it's not completely back to nature. You introduce some natural component into the urban setting. So it's more like an eco-technological, as mentioned. And in Japan, super levee case is a social-technological, extremely costly, but the residents can come back to their old places. So there's a difference between the Willing Sellers program where residents cannot come back. So has there been any regime shift in flood risk management? We found that there's still those cities rely on the resistant strategies such as levees and pump stations and underground tunnels. But some cities now introduce a more resilient approach. Now in Seoul's case, they designate and also coordinate with like a spatial planning. So they specifically identify the vulnerable location. They go out and outreach those population to educate people. In Tokyo's case, they created super levees. But we haven't found any transformative case except maybe the first floodplain restoration may be considered as transformative because it's completely moving people out and fundamentally shifting the thinking. So, but there are some challenges. You can see, according to city's 2040 housing development plan. So they still have some plan to develop more apartment condominiums in flood-prone areas. According to recent projection of my former student and other colleagues, you can see the Willamette River and adjacent areas are not necessarily safe to build buildings. So this is the issue. So we have to coordinate the spatial planning with flood risk. And with that, I'm going to just skip this. So some conclusions, the flood damage is highly related to the conversion of natural area to developed area. We have to understand the past, the history of development, and also to some extent, the policy change associated with those heavy rainfall events, but there are always some time lag. In the past, the technological strategies are dominant, but now we have more emphasis towards social, but still the ecological strategies are lacking. And we also identify some utility of using the SET approach to understand the different strategies. But again, the climate change can challenge the future of flood risk management. So which illustrate we need to really coordinate a flood risk management with spatial planning. With that, thank you very much.
Thank you so much, Dr. Chang, for a wonderful talk. We've got some questions that folks have put in the Q&A. I'm going to kick that off right now. So how about, Are you familiar with the project currently being implemented to control flooding on the Red River in Fargo, North Dakota, or Moorhead, Minnesota? If so, can you talk about whether the approaches are comprehensive and representative of social, political, and economic cooperation? Are the approaches equitable to all impacted by flooding?
I heard about that, but I honestly have not followed them much, so I cannot probably answer adequately at this point. But it would be interesting to learn their perspective. Yeah.
All right, to build on that, to what extent have you used geostatistics in your flood analyses?
Great question. So the first part, so I didn't actually show all those details. So basically there are two parts. One is we have old maps and we digitize those maps and created old channels and we compare it to the current stream channel, and we can estimate the curvature, how the stream channels got evolved as a result of stream strengthened or development. And then the other is the spatial regression analysis. So in the flood damage analysis, we have those are flood damage, but the flood damage, all the geospatial data are not independent of each other, as you know, the spatial correlation. We did take that into account in our regression analysis. So that's why we compare the OLS with hierarchical linear model with a spatial lag.
And to build on that from the same individual, why did you select snowball sampling for the human sample in relation to its lack of statistical validity? What was your thinking behind the snowball sampling of the human population?
Oh, so basically what we did was an expert interviews. It's not really a survey because I only showed the glimpse of all the interview results. So we rely on those experts, but there are not many, like 100 experts in each city. There only about maybe 24 experts. But and then at that point, the sampling is saturated. So we just stop and you get pretty much a similar story from those people that, you have done this social survey. So then I think it might be sufficient to have like 10 to 20 people who represent different departments and also different background. So, and then we can identify some of the common opinion about each city. Yeah, that's why, yeah.
Thank you for that methodological background. It's really helpful. Next question. Really, really interesting study comparing the 3 cities. Do you have any research that may indicate other cities which could have transformative policies?
So we have done, not to the extent that I presented, but as part of my other research with other researchers, the Arizona State and Georgia State. So we actually compare 6 US cities and look at flood vulnerability using a SETS approach. So we look at Portland, Phoenix, and 4 cities in New York City, Baltimore, Miami, Atlanta, Georgia. So those 4 cities in the east side. And then we use those social, ecological, and technological dimension and identify vulnerability indicators. So to look at which part of the city are more vulnerable in more than one dimension. So then maybe the area, let's say a particular census block group is very vulnerable according to both social, ecological, and technological dimension. Maybe the city can invest, this may be the hotspot, because these are all vulnerable based on all those dimensions, and we can improve that situation. Yeah, we have a paper published in Sustainable Cities and Society, and so if people are interested, then we can send it to folks. Yeah.
Thank you for that. All right, last question just for you, Dr. Chang. Flood mapping and zoning is often used to benefit business and other over vulnerable groups. What types of organizations are best suited to combat these effects? How can we avoid having our own maps used for this?
This is a great question.
That's an EMCR student question.
This is a great question. So the thing is underrepresentation of those vulnerable population who doesn't have a power. And Alida mentioned about whether are we addressing the equity dimension in all those hazard risk mapping. And I think this is just a great area if any EMCR students are interested in looking at this dimension. We have to understand the community's perspective rather than what I showed is somewhat more like objective. It doesn't really have any voice from those vulnerable communities. So what they perceive and what they value, right? So when you have multiple indicators, the community group may prefer this indicator may be more important than the others. And we have a way that we can weigh differently and have create a new maps based on different weighting. Okay, so I think that's so. What type of organizations? So I think the community, neighborhood organizations, or whatever, any racial group. Let's say the thing is sometimes those flood prone area, vulnerable areas, a disproportionately higher number of ethnic minorities, the Black or Hispanic or some Asian group. So then we may have like community centers. We can probably reach out to them and get their opinion. And sometimes the communication is also important if we don't translate. And some of those immigrants, they may not speak English, so they may get, even though there is a warning, if we don't send a message to flood warning using their own language, they may not receive the right information. This is again, the emergency management, the communication using the right channel and right language to reach out to diverse communities. It's important.
Thank you for that answer, Dr. Chang. I'm going to invite Dr. Cantor also to join us. Welcome back. And are there any questions that folks would like to ask both panelists? If not, I will pick from the list here. There's some great stuff. All right, lower income communities often have less green space and more non-porous services. Would that make them more prone to flooding?
In general, yes, but if you look at the water cycle that Alida mentioned, the trees can also intercept water and hold more water on the ground. So if you remove all the trees, there's much a shorter residence time. So rainwater can eventually just wash immediately versus the trees and any underground soils, less impervious surface, those areas can hold water and delay the runoff response time. Yeah.
Excellent. Dr. Cantor, what other systems beyond water markets and first in time are in use or could be considered to manage water resources?
Yeah, that's, well, first of all, thanks, Heejun. Really great talk. I really enjoyed it. But yeah, as to the question about systems beyond water markets, this is something I've been thinking a lot about and have done some research on. One of my own personal favorite policies is the public trust doctrine, which I think gives us a really amazing alternative to either markets or prior appropriation. And so this is a doctrine that basically puts government back in, like giving a government a more of a responsibility role and saying that governments actually have the responsibility to manage water for people and, you know, like for the good, common good, basically. And so the public trust doctrine has actually been used in a number of states, including California and Hawaii, to take water out of either like private hands or out of the prior appropriation system and put it back into ecosystems because it's for the common good. And so that's like a really powerful, amazing policy tool that I think has a lot of potential to be used more.
Thanks, Dr. Cantor. We have time for about one more question here. Trying to find one both of you can speak to. We have students here that are concerned about power dynamics and water. And there are some folks who are sharing that they feel that water policy gets driven by different entities such as corporate interests or business interests. We've heard that today. And that there might be, let's just say certain folks have more authority over water and water mitigation than others. What for the future do you think would be some equitable practices on how we can think about sharing water, or, you know, different ways in which in the Anthropocene humans don't outcompete each other for a resource, but rather develop some forms of institutions or policies to manage it better? What do you think?
Maybe my Alida can better answer the question, I think.
I can take a step. That's like such a big question and such an important one to think about. I think there's a lot of really good examples already out there. There's work like, for example, by the scholar Eleanor Ostrom, who studied groundwater management as a commons and showed, came up with all kinds of examples where people are in practice managing the commons in sustainable ways by working together. And her work is such a good example of, she outlines like the rules for successful management of commons through institutions. So I think we can learn a lot through that. I think, like I mentioned, like legal and policy approaches such as the public trust, which emphasize common good and give government a role in protecting common good. And so I think there actually are like quite a number of tools out there, and it's a matter of like shining light on those tools and like actually existing practices and like lifting them up. And that's, I think, a really important thing to do.
I can just add maybe a 1,000-foot level answer. So in terms of engaging those historically excluded or underserved communities, because those communities are also very busy and they don't have time, so we may provide some incentive for them to participate in whatever the larger conversation. When you have a community gathering, it's always whose voice is dominated, whose voice are heard. So if they don't participate, there's no way we can actually address their concern, but also we have to acknowledge that they may not have resources to participate in terms time-wise or resource-wise. So I think we should probably identify a mechanism. I don't know what that may be, but this is something that we should be very mindful of their potential constraint to participate in those larger conversations.
Thank you both for those responses. It really showcases how in the EMCR program, we're trying to look at these complicated problems from different scales and to think about them in different ways. Today, we were able to showcase our geographers, and it's just so spectacular to see the contribution one discipline is making to the EMCR transdisciplinary curriculum and how the work of these scholars spans different scales and engages different questions that are extremely pertinent to what's going on here and elsewhere across the world. So I want to thank everybody for joining us today. I want to thank again both Dr. Cantor and Dr. Chang for very engaging talks. And I want to thank everyone who joined us for one or more talks in the Practicing Resilient Futures speaker series, or Toward Resilient. I'm already on to the next one, the Toward Resilient Future speaker series. It's been a wonderful way to generate community, to get the word out about EMCR, and now is a wonderful opportunity to welcome our students and fold them into our networks. So thanks again for being here today. Please check out the recordings from our other talks and stay tuned for some emails related to the new speaker series starting in January. Thank you for everyone, and have a great day.
Thanks, everybody. Thanks.